Here we have a problem where we're calculating the equilibrium concentration of H2, and we're given a value of K for our balanced chemical equation, and we're also given equilibrium concentrations of all reactants and products except for H2. So we're going to start out by writing out our equilibrium constant expression. So here's our equilibrium constant expression. As usual, we have the concentration of our products raised to their coefficients. So here, the H2O is a product, its coefficient is 7. So we have the equilibrium of concentration of H2O raised to the 7th power. In the denominator, we have our reactants raised to their coefficients. The question is asking us to solve for the equilibrium concentration of H2. So we're going to solve this expression initially for H2 raised to the 14th power. All right, so here we have solved for H2 raised to the 14th power. Again, what we're interested in is a concentration at equilibrium of H2, not H2 raised to the 14th power. So we have to take the 14th root of H2 raised to the 14 to get our H2 value. Now we can substitute in our numerical values from the problem and solve for our equilibrium concentration of H2. So here we've substituted in our numerical values from the question statement. Now using our calculator, we get a numerical value for all of this on the inside. When you do it, you should get this value here, 0.21157. And we're going to raise this value to the 1/14th power. Now when you're putting this into your calculator, make sure you include these parentheses. And we get to our final answer of 0.89 moles per liter.